All right, let's get started. I'm Max, co-founder and CEO, and we've got a special session here to talk about our new developer platform. So some of you may have seen the announcement we made in October announcing these new features. We're going to go through just kind of a quick overview of what they are, but I also have on stage a few of the people building all of these tools, and they're going to show you some new demos and applications, and then we'll have a little Q&A. I think more than most things that Formlabs has shipped, the developer tools are going to be much more interactive and require a lot of feedback from all of you to help us build the right thing. So that's we're hoping to get out of this. Great. So we just launched the 4L. And that is a big milestone for Formlabs. It's with the 4 and 4L, it's the 4th generation of our stereolithography technology. We've been working hard at this for like 12 years now. And what we set out to do when we started with the Form 1 is to make 3D printing much more accessible for professionals, but easier to use and more reliable, so that you can go from a 3D model to a part quickly and easily. And that's been always our core focus, and we put a lot of work into that over the years. Different features like one-click part setup, cartridges to reduce spills, quick-release build platforms, remote monitoring, and all these features are really focused on like a typical user who's got the 3D model. They want something out of a standard material, and they're happy with just print it and go. And that's still most of our users. But over the years, we've gotten a lot of requests for things that are outside of what our kind of standard platform can do. So people ask us, like, can I print this other specialty material you don't have in your platform? Or can I modify the settings and get even higher resolution out of the printer? Or I've got a lot of jobs to print, and I want to automate job setup so that no one's clicking around in preform. Or can I modify the settings to print a part faster? And many, many more requests. And typically, we've taken those things as input, as like, okay, maybe we can work on those features. But we've kind of stayed focused on what do most users want. And now with the 4th generation, we think we've gotten to such a great place on the standard, most common needs, that it's time to do a better job supporting all of these other things that people want to do, and to help people really build on our platform, where we become not a one-stop end-to-end solution, but a component that people can build something even more powerful on, that's built for their needs. And we think of this as the same way in the software world. There are developers and there are developer platforms that people build on. Think about like iOS and the iPhone, and how a world of developers have built amazing applications that have made iPhone more powerful for everybody. And so part of Apple's job is to make a great developer platform. There's different types of developers in 3D printing. There's people who are trying to make new applications where, like, get 3D printing to do a thing it couldn't do before, like maybe direct print aligners in dental or things like that. There's people who are running a lot of printers, and they need to maximize performance and minimize costs and fine-tune the system. And there's people trying to bring new materials to the platform that increase capabilities. So there's a range of types of developers, and we're trying to help all of them with a few different pieces of the system. So the Formlabs developer platform, we've got 3 components. There's open material mode. So this is the ability to run any material on any of our systems. Then there's preform print settings editor that lets you tune the print process for speed or accuracy or other things that you want. And then there's the Formlabs API that lets you automate using preform and fleet control. So I'll go through quickly through each of them, and then I'll turn it over to the team to go into a little bit more detail. But here's a really quick demo of what you could do with the print settings editor. Do we not have the video anymore? Maybe not. There's supposed to be a video here showing you how you could make 25 micron print settings. So we come with out-of-the-box settings for some layer thicknesses. Nope, I'm still on this one. Oh, there it is. So yeah, so if you wanted to run a material at a layer thickness we don't provide, it's now pretty easy to go in, create a new setting yourself, and try a different layer thickness, and potentially dial in some other settings if you're trying to get the accuracy just right. And there you go, you've now added a 25 micron setting. So that's pretty straightforward to do. Then, yeah, with open material mode, you get to use all of our all the capabilities we have in our printers, which I think make it one of the best platforms to develop on. So there are other open printers out there, but like for example, if you take Form 4, you won't find another desktop SLA system that has the temperature control for materials, that has the mixer that lets you run more viscous materials, resin dispensing and resin height control. All these things make it a really good platform to develop materials on. And then lastly is the API, which really can do a lot of things, but here's just one quick demo that I'm really excited about. This actually combines the print settings editing and the API in one system, and we call this speedrun.py. It's a little Python script that helps you optimize the print speed of a job. Usually you can get more print speed out of the printer than what we do out of the box with our settings. So this tool knows about a few different ways you can optimize print speed, and you can ask it to create some settings files with some of those speed ups, and then it will make jobs with each of those settings files, and then if you like, even upload them directly to a printer so you can try them out. Here it's showing a little report of the speed ups that I was able to achieve with the different adjustments, and as you can see, you can often find 20-30% speed ups on different settings. And this is really cool because typically it takes a lot of work and a lot of knowledge to get to this kind of process engineering. But if we can start to encapsulate it in little bits of code like this, we can make that more accessible to more users. And then the API is also going to make its way out to users in the form of off-the-shelf integrations with different CAD software that will be built using this API. So even if you're not a software engineer yourself or your company's not prepared to take on something like that, API is going to make the system more powerful for everyone. And that's true of all of everything that here in Developer Platform is. It should make its way into many users' hands, even the people who aren't developers themselves, either by bringing new materials to our platform or more optimized print settings or software integrations like this. So now we'll jump into print settings editor. Woody will share a bit more. And at the end, we're going to have time for some questions. So please think of some things to ask us or some feedback or feature requests you want for these systems.
Awesome. Thanks, Max. So I'm Woody. I am a materials program manager here at Formlabs, and I'm going to talk to you today about the print settings editor. To begin, what is the print settings editor? It is a tool that provides you the opportunity to modify the core printing parameters for our printers. So this allows you to fine-tune and control the machine as you see fit. During our tuning process here at Formlabs, we make lots of decisions on our print settings for reliability, for speed, for accuracy, that we believe is a great trade-off for the general user. However, for your specific application, there might be a better optimal set point for your print setting. So the print settings editor will allow you to tune and optimize for your workflow. I'm going to dive into 2 examples here today. The first one is going to having to do with alternative layer heights. So as Max showed previously, there was the 25 micron Tough 2000 setting, which allows you to improve the surface finish and fine detail with the trade-off of some slower print speeds. I'm going to talk about a fast arch, fast model 120 micron print setting that we've actually seen large dental labs utilize so that they can get the right trade-offs for their business. So the question they're asking is, what if I had a setting with finer layers, but I preserve the print speed of the 160 micron fast arch setting? So if we look at our available settings, we have 100 micron, which are a default setting, and that takes 24 minutes for this scene of arches. The Fast Arch 160, which we here at Formlabs have optimized for dental applications, does take 8 minutes, which is substantially faster, but it has some surface stepping, some artifacts that a customer might like. And then we have our default 200 micron, which is the same speed, with even more stair stepping. So I'm going to show you how to make the 120 micron setting. This will allow you to have less surface stepping than the 160 micron fast arch, while preserving as much speed as possible for this print, so you can make sure your workflow is still going efficiently and quickly. So this is a quick video of how to make the setting using the print settings editor. So I start by finding the fast model setting in the print settings editor. So I'm searching by printer type and by material. I'm basing this off of the 160 micron fast arch setting. I am then able to change the layer height and rename it. For this setting, I was able to change just this one parameter to get a print that showed me the ability to speed it up and get these better surface finish. There is still way more room to optimize and tune as you are developing your print setting. I then applied the setting via the print settings editor and got the print time estimate, which came out to 11 minutes. So going to see this setting was real, we did print things with it. So if you look, we have our 100 micron print setting, which is our best surface finish of the 3. But it took 25 minutes, which is much slower than you would want for a fast turn aligner manufacturing process. As you can see, the 120 micron fast arch is slightly slower than that 160 micron setting, but it is substantially better in surface finish and quality. So this customer is able to choose exactly what trade-off they want for their application. We do our best to make sure our compiled in settings create the right balance, but every customer is different, and this allows you to choose what you want. My next example is going to be with a custom outer boundary offset. So with color kit resin, there is some complications here as the user can define what color it is. Adding different pigments to resin can change how it prints, and most notably, its fine feature performance can vary greatly depending on what mixture you choose. At Formlabs, we tuned so the general mix of color will come out, but it's hard to cover every single edge case of this material. So I went to print this really fine detail part, and as you can see, it failed. There are substantially under-resolved features that were just not robust enough to survive the printing process. With the print settings editor, this can be addressed using the outer boundary offset parameter, which changes the perimeter placement. So you can get slightly larger features that are actually closer to the design size. I also found that as this is a short part, I did not need to wipe during the print, and I turned that off in the print settings editor. So going in here, what does this look like? So this is the interface for the print settings editor, and I have highlighted the outer boundary offset parameter. I adjusted this from 0.2 to -0.3, which dilates the layer by 50 microns. So this is makes it a little bit more robust and larger, which is more accurate in this application. I then went and found the wipe behavior pattern. I changed the parameter from -1, which is a one-way wipe, to 0, and I applied it. With these changes, I was able to get a fantastic looking part and also save a few minutes while doing it. This is just another example of how you can use the print settings editor to optimize for your workflow. This is another application that we've seen our customers use to get the best performance from our machines. While we do believe we make the right trade-offs for the general user, every person is different, and you can get a more optimal result for your application with this system. With that said, I do want to hand it over to Alex Haring to talk about open material mode.
All right, thanks, Woody. My name is Alex Haring. I'm on the materials team here at Formlabs, and I'm going to be talking today about open material mode. I think this is a pretty cool thing for everyone to work on because it allows all of our users in a way to sort of work the way we do on the materials team here and lets us really open things up to try whatever you want to do. So what does it actually enable? There's a few different directions you can go here. One is printing specialty materials. Maybe you have a niche application already that there's an existing solution for that's not in our resin portfolio. You can bring that onto the printer and pour it right into the tank and print with it. Maybe you're trying to do materials research and development, create your own formulations. Form 4 is a really nice platform to do that on because we have all of the print settings that Woody was just talking about that we can really dive in and tune it. If you have a highly viscous material, maybe something that settles, maybe something that is slow reacting, you need to really control the exposure, you can do all of that on the Form 4. And then finally, it allows you to share your settings, maybe with a colleague internally or commercialize and bring a material to market and have it available with settings on the Form 4 ready to go. So open materials mode has only been out for a couple of months, but we've already heard from our users over 25 different materials that have been printed on our printer, which is really cool to see. It's a wide range of things ranging from engineering applications to dental, medical applications, and it really shows all the different things people are doing. And a lot of this is existing solutions, but we're also starting to hear from our customers about new materials that they're developing, things that they're trying to work on for special applications, and it really shows what you can do with the Form 4 platform. So the first thing I want to talk about is materials research and development. The reason I like Form 4 for this platform, for this application, is that we can control things like heating. Like I said, maybe you have a viscous material, you can go up to 45 degrees C on the Form 4 and control that precisely. You can also tune the power. We have a really pretty powerful machine here, 16 milliwatts per square centimeter, and you can also precisely tune the exposure and how you want to deliver it. You can control the motor movement, both during the squish movement and the peel movement. And again, if you have a viscous material, that's going to really help you out in trying to get those nice parts out at the end. So one user we can talk about that's been doing this already is Polymed. They've been developing a bioresorbable material, which you may know is not in our 35 materials that we make. It's a really cool application, but not something that we've done ourselves. And we're able to see a customer who can go onto the Form 4 and create this sort of material and print successfully with it. And from talking to them, it sounds like the ability to heat the resin was really key here to get the viscosity in a range that they could control this and print it well. And so they're having good success with this and already starting to share it with the world. Another thing that I mentioned you could do is to print specialty materials. So something, maybe you have a material that already exists and you want to bring it on. Here on the Form 4, we have the wiper. So if you have something that settles out quickly, you can use the wiper to control that, or if it's a viscous material that you need to move around, again, you can do that. You can pour the resin directly into the tank, so you can get it just in a bottle and use it. And then you can modify the exposure and really tune it in. So one thing that's nice is you can start with our material settings as a base. So if you look at the TDS for a material you find on the shelf and you say, okay, the mechanical properties are similar to one of Formlabs materials or the viscosity is similar to one of Formlabs materials, that's a reasonable starting place for you to go. And then you can tune the settings from there to get it to work with your material. A couple of our customers that are already doing this that I want to bring up, Restore 3D, they're developing really interesting cutting guides and surgical planning tools, but they have a proprietary material that settles really quickly, it's highly viscous. They're able to use the wiper, and you can actually tune the way the wiper moves, the speeds that it moves at, to prevent that from happening and allow them to print this material on the Form 4 with good success. Another customer that's been using this is Figure Engineering. They've created this resist resin, which is a really durable material. It's chemically resistant and designed specifically for masking applications in like electroplating. So this is something that they've developed, and they've been able to tune not just the basic settings, but really every aspect of the settings so that it gets a really nice, highly accurate part that you can use for masking. And they're starting to bring this to market as something that customers can buy and comes along with Form 4 settings, which is the last thing I want to talk about, which is how you can share and commercialize your settings. So you may not have something you want to bring to market, but you have a colleague that has another site with a Form 4. You want to be able to share a material you've been developing with them, allow them to work with it. You can export your settings, share it with them, and allow them to have sort of the same experience that you are on the same platform and make sure you know that you're looking at the exact same thing. Or like I said, you could use this as settings that are available with the material that you wanted to sell yourself. And then on the Form 4, you know that you're going to get a really repeatable experience, which is nice. So what does this actually look like in Form 4? In Preform? Is just like Woody was showing you in that print settings editor, you have this button to export and share. It just shows up as a FPS file, which then you can import into preform. You only need to do that once. Once you import it, it stays in preform. And you can see that once you've loaded that up and applied it as your material, it displays in preform as though it were just one of Formlabs materials itself, which is really, really nice and makes it easy to use and easy to share. And with that, I'm going to turn it over to Jacob.
Thank you. My name is Jacob. I'm on the software team here at Formlabs. I'm going to talk about the Formlabs API, which you can use to develop custom integrations and automations with Formlabs hardware and software. So really the main takeaway, what I want you to get for the API is if you have a repetitive or a manual workflow, you can consider automating that with the Formlabs API. The Formlabs API can fit in on all parts of the manufacturing flow, from design to coding and review, scheduling and printing, to monitoring your fleets. So example uses include integrations into design or CAD software, estimating material usage during quoting or print time, using speedrun.py to make the print faster, as we saw, getting the status of your printers and automating job preparation, batching jobs together, creating printable job travelers, and importing your print history and printer status into an MES or other software system. So I'd like to show you a couple of examples about what building an integration might look like. So the first one we'll look at is integrating your printer status into an MES, or a manufacturing execution system. This is a tool you can use to track the stages of a part going from different manufacturing stages to delivery. And we'll be looking at Tulip as the specific example. So within Tulip, you can make dashboards like this of your manufacturing floor. Here we're looking at, for a print farm, the distributions of the materials loaded in each of the printers. So as orders are coming in, you can rebalance and change the materials in printers to match that. Within Tulip, you can also use their no-code platform to build apps for operators on the floor. So here is an app giving operators visibility about what's in the queue, if anything has issues, so they can jump on it and look into that printer. Both of these things are looking at the live status of printers, and that's really easy to do within Tulip using their web connectors in the Formlabs web API. So here we're using one of our API endpoints and deciding what fields we want to pipe into the no-code platform to build those apps. In some cases,
I just want to add something on that example. What's really cool about that previous slide is this is building an integration between our system and this MES software without any code involved. So it's pretty much just kind of this interface you see there, and so there isn't a very high barrier to entry for this stuff. You can start putting together automation without a lot of software engineering expertise.
Yep. And another way, if your process is even more informal, we see a lot of people tracking things in spreadsheets, and you can use the API with that as well. For example, a common thing we see is making a printing log. So things you're printing across your printers, you're typing in the job name, which printer it was, when it started and stopped. You can also automate this process of filling in this information using the Formlabs web API. Using Google Sheets, that's really easy. You create an app script and this little snippet of code, and it'll automatically pipe that data into your spreadsheet, so you don't have to manually type that in. And next, we'll look at what automating a job preparation looks like. For example, if you're a high-volume user printing a lot of the same parts, for example, a dental lab. I think they're going to play the video. So this is a script we call autobatch.py, which is a Python script monitoring orders coming in on a local folder. So when a new folder is detected, the script starts running and automatically goes through the steps of job preparation. And here, it's not only setting up the models, it's also figuring out how many fit on one build platform, and if needed, we'll create additional build platforms. So in this case, it needed 2 to fit the number of parts. And not only can it do that, it can also upload to Fleet Control or directly to printers to automate the entire job preparation workflow. Here we go. So looking at that example, if you're a high volume user, maybe you're having someone sit in preform manually importing parts, doing the same steps. You could automate those same steps in Preform and use our API to build a script to do that. Here we have the scripts built in Python, and we have an official Formlabs library for using our APIs in Python. But you can use any programming language, as we saw in the MES, build things without code as well using our APIs. So if you want to get started, we have our developer portal on support.formlabs.com. We have API documentation, example code, inputs and outputs, getting started guides. So it should be really easy to jump in from there. And if you're looking to get help, we have a section on the forum for developers. You can also email apiinquiry@formlabs.com for more help. And finally, what I've talked about is if you're a developer or if your company has the capacity to build custom integrations, but that's not always true. Sometimes you wish there was just a plugin you could install without having to do any work. So please let us know what those are. We're interested in partnering with other software companies to build these integrations so they can just be a one-click install. So, with that, I think we'll open it up to any questions we have right now. If not, we'll also stick around for any other questions.
This is, I think it's supposed to be a coffee break now, so feel free to get up and take a break, but we'll keep going here if there's questions.
Do you plan to keep any kind of like centralized repository of community-derived profiles for open materials?
So I think I'll repeat the question. I think the question is, are we going to support some kind of community system for sharing print settings? And yeah, that's absolutely part of the roadmap for print settings editing. Today, we don't have a special purpose system for that. We've got our forums on our website. It's a good place to share things with our community. But right now, we're getting a lot of feedback on what people want to do with print settings editing. And over the next couple of months, we're going to take that and try to turn that into some better ways to support people sharing settings. Because I think that's one of the most powerful parts of the system is there's so much great work being done optimizing, getting the most performance out of the system. If we can make it available to other people, it's going to make it more valuable. If you have specific ideas of what you'd like to see in a system like that, love to hear it.
Yeah, sorry, quick question. Is the idea later to implement those items as well from the API? Let's say we have a lessons learned over time into the dashboard as well, or is it up to the user?
Yeah, so the question is, will we take some of the things that we see people building with the API and build them into our software systems like Dashboard and Preform? I think that's one of the things we expect to happen. If there are particularly popular types of integrations or little add-on scripts like some of those demos we showed that are very popular, then that's something we would make a first-class part of our system and support really well. But this is also another area where I think we can support the community to share best practices with each other. We added a little section to our forums specifically for developers, and there'll probably be activity on GitHub and other places like that.
Is it possible currently, or is there a plan to implement adaptive profiles so I could, change print settings based on wall thickness or Z height?
So repeating the question, is, are we planning on implementing adaptive print settings so that they can be adjusted on print parameters or model geometries? So we do have adaptive settings based on kind of layer heights and angles for the Form 3 and Form 3L. This is something that has been in talks about for next-gen printers as well, but they are not scheduled for any release dates or anything like that.
I can't build my own either.
We do not have a workflow for you to be able to build your own in the current print settings editor.
You could build something like that by if it can work within our existing print settings, then you could do your own geometry analysis and tweak settings specific for a job. That would be a way to sort of hack something like that. The print settings we have exposed today is a subset of all of the print settings in the system, and we do have geometry adaptive features in our system. We are planning on exposing more over time. Some of the geometry adaptive ones are more difficult to use and more difficult to document well, which is why we didn't throw them out there immediately. What's the specific thing? Is there something you have in mind where?
We're printing a lot of physiological stuff, and so you end up with some really, really small features and some really, really large features, and it'd be nice to be able to like change power on the laser whenever you're printing those really small features, so you don't end up clogging them up like, say, an inner ear. Whereas, when you're printing the rest of the skull plate, you probably, don't need to be quite that fine. Maybe you want to go for the higher power for the better speed. Just kind of thoughts as I've been talking to a few of your engineers on things that might help us with getting some of these really fine features tuned in. So I was curious if they were in the pipeline anywhere, especially with the open material and the advanced settings and all these fun things coming out. So thank you.
Thanks.
This is kind of two questions, I guess. Is the print settings editor and open material model, is that like the same license that you buy for both? Or is PSC already like available for use without the
Print
license?
settings editor is free and included in preform, available for everybody, and open materials mode is an extra charge per printer.
Gotcha. And then does the print settings editor, is that for SLS as well or just SLA?
Yep, it's for SLS as well. Yeah.
Okay.
Regarding your dashboard and fleet control, is there any plan to make that more of a local control rather than using a cloud service? Because, for example, in aerospace, we have security concerns and we simply can't use the cloud service to do those kinds of things.
No offering for that today, but using the API, you could definitely build something like that, either yourself or if there's enough interest, we could use the same tools to develop that. So
Thanks.
that's the idea of making this local API.
Yeah, one of the things, I'm not sure if it was clear in the talk, is that API has some functionality that connects over the internet and connects to dashboard, and some that just works with preform. So if you're just using the local part of the API, you can build some features like that.
Just, I guess, a quick clarification. For the open materials that you guys are running, you said you can generate a file that can then be used to use that material on other printers? Did I understand that correctly?
That's correct, yeah. So you can export the settings that you've developed and share them with other people. If they want to run the material, if it's not a Formlabs material, that other printer would also need to have the open materials mode. But yes, you can
That's
share
what I
the
was going to
settings.
ask, is if you'd need open materials mode on any other printers that you'd be deploying this new setting for. All right, thank you.
The settings setting system is available with all printers. Open material mode lets you run a non-Formlabs material on a given printer. So any printer that you want to run a non-Formlabs material on needs open material mode.
Three short-ended questions, so they're not all long. One, would there ever be implicit format? 2, 3MF. 3, would there be a communication protocol where robots can interact with the printer?
The first question was an implicit format, or that's like exporting a scene or a setup into an implicit format, or?
Yeah, directly. Whether right now I do a lot of latticing, and when I do my intricate thing, it turns out to be gigabyte plus STL, and there's no way to reduce it without compromising its detail.
Yep.
So printer can definitely handle it. Just that. So don't want to mention other people's names, but like they adapted like implicit file format directly. And is there any roadmap for that? Because the only way to do latticing is 3D printing, and it kind of asks for it, but not see the option. So the second part was a 3MF, the same thread. It has more information than just
Right.
coordinates. So it is necessary. And the final question to iterate is the communication protocol. So
Great. So to kind of summarize, I guess, some of your questions, the first is about being able to export scenes into common formats like 3MF or other formats. Currently, API is designed for the common printing workflow of importing the models and then going to our printers. In terms of exporting the models again and using them on other software is not something that we see a lot of people using.
He's asking about, can we import implicit CAD like from Entopology or something like
sorry,
that, and not
misunderstood,
go
yeah.
through an STL mesh?
I see. Okay.
Yeah, not something we currently support. Actually, don't know of any 3D printer that supports importing in. There's some that EOS and others support slice files as an interface.
There's another
Yeah.
one. I want to not do STL.
I see.
So far, every time we've encountered this, my response is, give us your nasty STL file and let us try to import it. And I think haven't found too many cases where we can't.
Yeah, I agree. I did that. It's just that my computer almost burned down.
It is slow to load for sure.
Yeah.
But I think that's.
I have like triple 6000 series NVIDIA card. They almost burned down. So I'm just exaggerating a little bit. Yeah. How about the communication protocol?
Yeah, so the communication, I think you asked like being able to detect the status of the printer and like do other robotics around it. I think that's definitely a use case the API can support. It can already expose features of the information, its current status. The printer does have other checks in terms of its safe operating condition, which you'd have to work around. But I think some sort of robotics would be possible. We'd have to chat more.
An API endpoint for a fuse that unlocks the door is probably something.
Oh no, that would be.
I think,
I don't know.
I think we can do that.
Yeah, we can do that. Yeah. Yeah. If it's safe. Yeah.
Did it already, but I don't want to do it again. ESP32. Thank you.
Yep. Thanks.
So kind of following up with him, and so you mentioned that you can support step files now, and so dealing with implicit files, I have to mesh them, so tessellate them, and then bring them in. Now they're kind of faceted. Is your step import function also like tessellating them, or do you think we're going to have like smoother features because you can kind of get faceting around stuff?
Internally, Preform still has a mesh representation that it's using. So yeah, when you import those CAD files, it will tessellate them into a triangular mesh. Typically with things that are in step files, that's not a problem because you can mesh them at a very fine resolution. For those lattice type structures, those can be a little more challenging.
I have one more. And then, so I print big things that have large, long ventilation holes. They're only like 1 millimeter long, so long, thin cylinders, and they kind of get filled in sometimes. So I have to over-design them in anticipation of them shrinking. But this, boundary expansion, that would fix that? Or no?
So just repeating the question is, you print long channels that you often find are filling up due to dimensional inaccuracy from this hard-to-print geometry. So the outer boundary offset will work very well for vertical channels, things in XY. If your channels are horizontal, that's much more difficult to compensate. When you expose resin to cure it, the light goes into the resin. There's nothing to stop it curing other than just how much the resin blocks it. So outer boundary offset will only really affect XY geometries, much less so than Z geometries. Does that answer your question?
Yeah.
Cool.
But yes, you can. I'm pretty sure with any of our default settings, you can improve the fine channel performance if that's all you're trying to get out of the setting. If you're willing to maybe compromise with accuracy in some other places, and that's something I'd suggest email Woody and ask him for some some tips.
Yeah.
Outer boundary offset would be one.
Boundary offset, reducing exposure, particularly for horizontal channels, because that's kind of how your finger drew it. The less exposure you can give and still get a reliable part will be very beneficial. We call this phenomena Z-bleed because you're curing more than what you ideally want. So we try and tune with that in mind, but 1 millimeter channels are a very hard to print geometry.
Wiping 2 ways is probably another
More
good
wiping
thing.
can be helpful. There's lots of ways to really squeak out that extra performance at the cost of other things that a lot of other users would not like to make that trade-off with.
I did work with a medical device manufacturer who had this need for some microfluidics channels, and something we did for them actually is gave them an additive for the resin that actually basically makes the resin print better at finer layers. It reduces that Z bleed. So that's something that we haven't commercialized, but it's we could if you got a specific application, we can try sending you some additive like that, and yeah.
Yes, sorry.
In that sense, for that application, how do we know to go to you for that additive?
Can you repeat the question?
I said in that instance where you just gave him an example that you used an additive in order to provide a solution, how do the general user population know to go to you for such an additive?
It's not a widely available feature right now, but come and talk to us after, and we can see. I think we can do a little bit of experimenting with it.
For SLS printing and being able to adjust all the print settings, are you able to see an increase in the properties of the material? Like if you were to increase layer height, are you seeing more strength, or is it just pretty much staying the same?
You can get better mechanical properties in SLS by fine tuning. So there's often some kind of, especially in SLS, there's a lot of trade-offs, but generally putting more laser power in and higher temperatures of the bed will improve mechanical properties, and then you may start to see other surface finish or other problems. But that is, there's definitely a lot of room for tuning for mechanical properties.
And there's places that we can go online to learn more about all that fine tuning and understanding how those different settings work, or is it just trial and error?
Right now, the documentation we have, we sort of explain directly what each knob does. We don't have all of the guides on if I wanted to increase mechanical properties, which knobs would I use? Again, I'd encourage you to come up after and we can connect you with the right people who can give you some of that input. But this is part of we're steadily releasing more documentation of these features every week or two. Great. Well, thank you all. And I guess we're on to the next section.